Welcome back. Today we're going to look at the product rule for derivatives. First we want to recognize where the product rule comes up. Product, of course, comes from multiplication, and so essentially we're looking at an expression multiplied by another expression. Up to now, all we've been able to solve are things that look, individual terms that look like this, possibly with a constant out front. And so what we would have done was multiply this all out, get each individual term in terms of some sort of polynomial, and solve it at that point. That's fine, of course, until we end up with something that starts to look a little bit too messy. And now, obviously, multiplying this out doesn't seem like a very good idea. Okay, so eventually we'll be there. We're not quite there yet, but the starting point to get there will be to understand the product rule. So this is the product rule to differentiate something of the form f at x times g at x. So essentially what could be a function by itself times what could be a function by itself. So an entire expression times another expression. We do f prime at x times g at x plus f at x times g prime at x. So essentially differentiate the first one, leave the second one alone, and then add the first one left alone, the second one differentiated. So I've got a few examples here. I'm just going to go through them. Again, it's going to be a fairly easy thing. How we're going to take the derivatives of each of the terms will be the same as what we've done before, and then it's just a matter of keeping track of the expressions afterwards. A lot of calculus is just doing the algebra after the fact. So starting with f at x being x plus 2 times 6x squared minus 2x, we said we take the derivative of the first term. So I've written it this way simply because it's a little easier to visualize. I'm taking the derivative of the x plus 2, leaving the 6x minus 2 or 6x squared minus 2x alone, plus, that's from the equation, f at x as it was, x plus 2, and then the derivative of the second expression. The red is the derivative, the blue is the original expression. And of course, once we've done that, sort of the derivative of x plus 2 is x to the 1. Again, 1 comes down multiplied by any term out front, any coefficient out front. So 1 minus 1 is our exponent, our new exponent. The value 2, when we take the derivative of it, we get 0. 6x squared minus 2x, still there, plus x plus 2. So again, none of this has changed at this point. And now we take the derivative over here, 2 times the 6 out front, x to the 2 minus 1, minus 2 times the 1 exponent multiplied by the 2, and then 1 minus 1 up there. And now it's just a matter of simplifying. This is 1 times x to the 0, and so really this whole red expression here becomes the number 1. So we have 6x squared minus 2x. Over here we're going to have 12x exponent 1 minus 2, right there. And now we will multiply the second expressions, the second set of binomials over here, and find out what our final result is. Okay, so simplifying in the last step. 6x squared plus 12x minus 2x minus 2 more x plus 24x, and then the minus 4. So again, the only thing that's new here in any way is just to know that this is the pattern for the product rule. We take the derivative of the first part, leave the second one alone, leave this first one alone, and we're adding, of course, and take the derivative of the second term. So, second example here. G at x is these two terms multiplied. We'll take the derivative of the first term. 3, we're left with x squared. The 1 comes down, minus 2. So again, red is your derivative. The blue terms are the original terms. So the second term is left alone, plus first term left alone. And over here, 2 times 6 is 12x, and we have a 0 for the second part of that. Red terms are derivatives. And now again, doing the algebra to simplify, we will multiply these two terms, these two binomials, multiply these two binomials and add the results. So I won't go through all that, but assumedly it was done correctly at the time. Example 3 down here. I don't know why I just did that. Okay, so a simple term here. Initially, this looks like we've got a division, and of course we do. But with the product rule, if we can rewrite this as a product rule, then we can work it out. And so in this case, we have 2x squared is the numerator. Root x plus 2 can be rewritten as x plus 2 to the exponent negative 1/2. And now we have two terms being multiplied. Each is in the form that we know, the x to the n sort of idea. So this expression, we'll take the derivative, get the 4x. This expression we'll leave alone, plus the 2x squared, and then we take the derivative of the second term. Sorry, I paused there for a second. So we've taken the derivative of the first term, left the second term alone, left the first term alone, and now as we take the derivative of the second term, 1/2 times this, and this is 1/2 minus 1 over here. This isn't a great example, and we'll see why at a later date. It actually is correct, but normally I wouldn't have wanted to do this, so that's what threw me off a little bit. And now basically we have a lot of work. We have 4x. This is root x plus 2. Again, the minus suggesting we did that it's in the denominator. Over here, a little bit of simplification. The 2's have canceled. I have a negative x squared. Sorry, the 2's have divided out. I shouldn't say canceled because it throws people off. People think of it as canceling, but again, really I've got 2 times all of this and a divided by 2, or 2 times negative 1/2. Whichever way you want to think of it mathematically, the 2's do divide each other out. And on in the denominator now I have the x plus 2 to the 3/2. Obviously when I was doing this I was debating whether going to roots was a better idea or leaving it as fractions, because I kind of got halfway here. And now it's a matter of kind of going through and doing the math. Minus out front, x squared. We're going to be looking for a common denominator. The common denominator is x plus 2 to the 3/2. So we need another x plus 2 in the denominator here. X plus 2 to the 1/2 times x plus 2 to the 1. It's x plus 2 to the 3/2. When we multiply the top out, 4x squared plus 8x minus x squared, 3x squared plus 8x over the denominator. Okay, so I'm going to stop there. Again, really the full intent and really all you're seeing today is that this is the product rule. You've got two terms being multiplied. We differentiate the first one, leave the second alone, add the first one left alone, second one differentiated. Now it does turn out, we may not see any, I don't think we'll see any today, but if you did have a third expression times something like x minus 21, we would just continue the pattern. Derivative of the first, leave the other two alone. Plus derivative of the second, leave the other two alone. Plus derivative of the third, leave the other two alone. So that pattern does continue. Again, likely won't see any of those today. And as far as, I'm sure I'm going to get the question, sir, are you going to give us that formula on a test? No. Again, it's not a formula. I don't believe in memorizing formulas, but this is not a formula. It's the pattern that emerges. We take the derivative of one part and the others can be left alone, and then we add the derivative of subsequent parts with the other expressions left alone. So it's just a sort of understanding of that's how it works out. It isn't a formula that you have to memorize and plug numbers into. So no, you will not see that on a test. If by the time we get to the test you don't know that you need to take the derivative of the first part and leave the second one alone and then do the opposite, then you've missed some pretty important parts, some pretty important information. Okay, I'll post this shortly and put up some questions. I don't know why I just told you that, because of course you're hearing it right now, so you know that I've already posted this and I've probably already put up some questions.